Okay, everybody say hi, Jake.
Hi, Jake.
All right, hope you're doing well. Okay, page 385, number 32. Okay, 32. Okay, it's the log base 8 of 16. The instructions on this one, this is the last of this set that we try to do this without a calculator. Now, we have to figure out 8 to some power is equal to 16. We got to figure out that power because that's the answer here, right? Now, when they're different bases like this, it's kind of hard to deal with, and I can't just like multiply this by 2 or something like that when this exponent's unknown. So what I'm going to do is 8 is 2 to the third, okay, and I'm going to just use x where the box was, and then 16 is 2 to the fourth. Now we got a common base, and power to a power, we multiply exponents. That's 3 times x is that exponent, and that's 2 to the fourth. And when we have a one-to-one correspondence here, so we just have to set these exponents equal and solve. Okay, so this answer is 4/3. Okay? That makes sense? If you're going to do something like this, you got to try to see if there's any way of getting a common base on each side. All right, the next one I have is number 46 on page 385. And these are condensed. We're going to expand the expression. So it's log base 6 of w squared over v. What goes with division when we're subtraction? So we're going to have 2 logs now. Log base 6 of w squared minus log base 6 of v. All right, and then I'm going to pull that 2 in front with exponent property. Log base 2 times log base 6 of w minus log base 6 of v. Okay. Any questions? 48. It's natural log of the cube root of t. I'm going to rewrite it as natural log of t to the 1/3 power. All good? Remember that property with the radicals? And then I'll pull the 1/3 in front and make it 1/3 times the natural log of t using the exponent property of logarithms. All right. What was the next one I had? 50. Log base 4 of 11 b squared c. Okay, multiplying, what do we do? Add log base 4 of 11 plus log base 4 of b squared plus log base 4 of c. And this middle one, I'm going to take care of that exponent and put the 2 in front. 2 log base 4 of b. Okay. Number 58. Did anybody have a question on 50? 58. Log base 4 of the... Pardon? Log base 2. Okay. Log base 2 of x to the 4th times the square root of y over z cubed. Okay, I'm going to just go straight to, we've done a couple of routes today. The most efficient route was this. Where we took the square root and made it a half power. And then transferred that to the numerator and denominator. So it's, okay, it is a mental block. I've done this every single period. Keep trying to make that log base 4. But it's the x to the 4th and times y to the half over z to the 3/2. All right, are you seeing this? Okay. That's times, and that's division. So I'm going to go log base 2 of x to the 4th plus log base 2 of y to the half minus log base 2 of z to the 3/2. All good with that? And then let's deal with the exponents. So 4 log base 2 of x plus 1/2 log base 2 of y minus 3/2 log base 2 of z. Okay, these are, we've taken a smaller and expanded it. Now we're going to take something like this and try to write this. Okay? That's what the next thing is. And that's on page 386. Let's do 62 first. Is log base 5 of 8 minus log base 5 of t. Minus goes with division. Let's make one log out of it. It's the same base. Let's make it log base 5 of 8 over t. All right? We've condensed it. We had this, we condensed it to one logarithm. All right. 66 is the next one I have written down. 2 log base 2 of x plus 4 log base 2 of y. All right. First, let's deal with the properties. I don't want to do anything with the timesing until I have just logs and nothing in front. So that's log base 2 of x squared plus log base 2 of y to the 4th. And then what do we do with that? Adding goes with multiplying. So we'll get this down to 1 log base 2 x squared y to the 4th. Yes?
Alright, I get it. It's kind of a really stupid question, but like, you think it's possible to like if you had log base 2 of x squared plus log base 2 of y to the 4th, you can like factor out a log base 2
No.
like x squared?
No. It's an operation. It's not a variable. Okay? All right. But I appreciate. Okay, 70. 3 log base 3 of x plus 1/4 log base 3 of y minus 4 log base 3 of z. Okay. It's all log base 3s, but let's get the powers so there's no multiplying of them. right, log base 3 of x cubed plus log base 3 of y to the power of 1/4 minus log base 3 of z to the power of 4. I'm not saying to the 4th power because this is, I've never even considered this before, how that can get misinterpreted. All right. Now, plus is what? And minus is, all right, so let's multiply the x cubed and the y to the power of 1/4, and let's divide that by z to the 4th. Okay, on 70? Let's look at 74 then. Ooh, I got brackets. 2 times 3 natural log x minus natural log of x plus 1 minus natural log of x minus 1. Close the bracket. All right, this 2 will be last. Let's work inside the brackets first. Is everybody good that that's natural log of x cubed minus natural log of x plus 1? I didn't change much here. X minus 1. Okay. What's minus? Division. So I'm going to take natural log of x cubed over x plus 1, and this is also division, right? Times x minus 1.
Wouldn't it be x cubed divided by x plus 1 divided by x minus 1?
Okay. Good question. So you want to divide this by x minus 1,
Yeah.
right? Right, right. So if I keep, change, and flip, I'm going to have this. If I keep, change, and flip, we're good, right?
Yeah.
Okay. It's a good question. All right. And then this 2. It's 2 times. So I'm going to take x cubed over x plus 1 times x minus 1 and square that. Now you could distribute the square if you want, make this to the 6th power, make that to the 2nd, and make that to the 2nd if you want. If we wanted to condense a little bit more, I would be good here. I would be good if we went x cubed over x squared minus 1, right? Just go ahead and multiply those out and do that. I'd also be okay if you decided you wanted to distribute that, but there's several stopping places I'm okay with. All right?